Okay, today we're in section 4.3, equivalent fractions. Let's see. Yes, in example 1, we are writing equivalent fractions. What's important here is that you show me what you're multiplying or dividing by and that you do the same thing to the top and bottom. All right, so doesn't matter. All of you could have different work. Some of you could multiply top and bottom by 2. Then another person multiplies top and bottom by 4, by 5, by 10. As long as you do the same thing to the top and bottom, you have created an equivalent fraction. If it's able to be reduced, you can reduce it to create an equivalent fraction. So we have 8 over 12. Another thing that's important is that you use the same original problem for both equivalent fractions. You're always going to be asked to write 2 equivalent fractions, so you always want to use the same original fraction for both. So 8 over 12, I'm going to first multiply top and bottom by 2. Like I said, this isn't the only one that I could have chosen. I could have multiplied by 3, by 5, by 10, by 20, as long as I do the same thing to top and bottom. Could I reduce 8/12? Yes. By what? 4. I can reduce it by 4, or I could reduce it by 2. Either way, I have created an equivalent fraction. Lots of different options, lots of different choices. These are just 2 of the many, many choices that you have to choose from. So now I want you to give me 2 equivalent fractions for 4/16 and 2 equivalent fractions for 9/12. 4/16, give me some examples of what you multiplied or divided by, Laria.
4/16 divided by 4.
Okay, divide top and bottom by 4. What'd you get? 1/4. What else, Emily?
2/8. I divided like 1/4 of it by 2.
Very good. Divide top and bottom by 2 to get 2/8. Matthew?
I divided, I divided 4 over 16 by 4 and got 1/4.
Very good. 1/4. And Alex?
I multiplied by 32 and got 128.
Of course, of course. Hey, that's still an equivalent fraction. He multiplied by 32. All right, so I multiplied top and bottom by 2 and divided top and bottom by 2 to get my equivalent fractions. And all of the ones that you guys described were correct as well. For 9/12, I decided to multiply top and bottom by 3 and divide top and bottom by 3. You'll notice kind of that pattern just with me. I kind of like using the same number, dividing and multiplying. But that's just my preference. Whatever you guys used, as long as you showed your work, would be fine as well. So that's writing equivalent fractions. Now I want to look at example 2. And in example 2, I believe I'm simplifying. Yes, I'm writing a fraction in simplest form. So I take the fraction 12 over 30, and I try to find the largest factor that goes into both numbers. I can do this using mental math. Now, if I can't find it, I could divide top and bottom by 2 and then just keep reducing. Do you know what the biggest factor would be? What would it be? 6. 6 goes into 12 and 30, both evenly. I can divide top and bottom by 6 to reduce it to simplest form. All right. Do you guys know how to reduce these in your calculators? No. Okay. Enter the fraction and hit equals, and it reduces it for you. Okay. So that's a nice little feature that you can take advantage of. Go ahead and reduce 8/12 and 15 over 21. Hopefully you don't need your calculator for these at least, but you can use it if you want. 8/12 reduces to 2/3, and 15 over 21 reduces to 5/7. All right, so just reducing fractions. Now, in example 3, okay, I'm simplifying a fraction. It gives me a map on page 183. It shows me that in the United States of America, there are 48 we had a debate last hour of the pronunciation for this, so any parents who are watching this, if I say this wrong, I apologize, but 48 contiguous?
That's right.
Contiguous?
That's how you say it.
Okay, very good. 48 contiguous states. What does it mean for something to be contiguous? They're all connected. They're all connected. Okay, so what two states are not connected? Hawaii and Alaska. They're still considered to be part of the United States, but they're not connected. So out of those 48, 21 are coastal. So write a fraction in simplest form of contiguous states that are coastal states. So coastal to contiguous. Write the fraction. Coastal to contiguous. Coastal to contiguous. What is it? 21 over 48. Is that reduced?
I'm gonna check.
It's not.
And if you're not sure, put it in your calculator. Calculator will tell you if it's reduced all the way. So for every 16 states, 7 of them are contiguous. Or coastal, I mean. Okay, so guys, that's just kind of basically applying this concept to a word problem. You'll see maybe 1 or 2 word problems on your homework tonight. Shouldn't be any big deal. All right, now let's move on to example 4. In example 4, let me get to it. Come on. Okay, yes, variable expressions. To simplify fractions that contain variables. What's a variable? Yep, letters, okay, that represent numbers. Factor the numerator and the denominator. And I'll go a step further, do the prime factorization, not just factors, but the prime factorization of these terms. Then divide out the common factors. In this book, you should assume that any variable in the denominator of a fraction is not equal to 0. All right, so what does that look like? Well, let's look at example 4. It says 10xy over 15y squared. I need to write the prime factorization of each term. So what is the prime factorization of 10? I heard it. 2 times 5. Does everybody agree that both of those numbers are prime, 2 and 5? Okay, now you might say, well, I don't think I can do the prime factorization in my head. Well, if you can't, then you have to work it off to the side in the margin. You have to find it. What about the prime factorization of 15? 3 times 5. Make sure, guys, that you have only prime factors. Now, then we just break it down times x times y in the numerator. 3 times 5 times y times y. Why did I multiply the y 2 times? Because the exponent was a value of 2. So that showed me that y was being multiplied by itself 2 times. Now I'm going to look at the common factors and I'm going to reduce them. Because 5 over 5 is equal to what? 1. Okay, so it cancels out. Anything else cancel out?
2 y's.
The y's. Okay, so on top, what am I left with? 2x. And on the bottom, I'm left with 3y. Okay, this is one method of simplifying fractions. Okay, and this method is to break down the prime factorization of the numerator and denominator and then to reduce. All right, I want you to try to do the prime factorization of 15x squared y to the third over 30x. Okay, so 15 breaks down to, we already said it, 3 times 5 times x times y times y times y. Okay, over what? 2 times 3 times 5 times x. Now what can I cancel? My 3's, my 5's, and 1x. Okay, so what am I left with on top? X, y to the third over 2. And that's it. All right, go ahead. Who got that right? Who got that right? Okay. If you missed it, do you see what you got wrong?
Could have put x dot y dot y dot y dot y?
No. Okay, that's a great question. Eric asked, can you leave it expanded in your answer? And the answer is no. You need to write it as a power in your answer. Okay? We leave it expanded so we can reduce, but then we need to write it as a power in our answer. All right, so if you got part of that wrong on the second one, try to correct what you missed. Let's do the third one. 16ab squared over 40a squared b. Okay, so for 16ab squared, say it with me, 2 times 2 times 2 times 2 times a times b over 2 times 2 times 2 times 5 times a times b. Very good. Now I cancel out my common factors, 1, 2, 3, and a set of a's and a set of b's, and what am I left with on top? 2b over 5a. All right, who got it right? Who got it right? Very good. Now, that's one method. If you want to use that method for all of your homework problems tonight, you can, by all means, use that method. Yes. There's another method that we will begin to focus on later in this chapter that I'm going to go ahead and introduce to you now. And this involves quite a bit of mental math, okay? 12/18. You're going to go ahead and just reduce it like a normal fraction. If you can't do it mental math, use your calculator to reduce 12/18. 12/18 reduced to simplest form is going to be what?
2/3.
What is it, guys? Okay, just let everybody else think. Okay, it's going to be 2/3. 2/3. Okay. Now, I look at my terms that have the same variable, top and bottom. So, on top I have a to the 4th, and on bottom I have a to the 6th. Do you see that? So, for the common variables, I'm going to subtract their exponents. What is 6 minus 4? 2. And I leave my leftovers where the larger of the two exponents is. Since a to the 6th is in the denominator, I'm going to put a squared down there, my leftovers, after I subtract. So look at my b terms now. What are my exponents? 5 and 2. So when I subtract them, what do I get? What do I get when I subtract? 3. And my 3, I'm going to leave in my numerator because my 5 is the larger of the two exponents. Let's look at our c terms. Well, in the numerator, there is no exponent. What do I know to be understood, though?
1.
A 1. So what is 3 minus 1? 2. And where do I leave my 2? In the denominator, because that's where the larger exponent is. And that's my answer. So you see, guys, I simplify the numbers, and then I simply subtract my exponents and leave the leftovers where the larger exponent is in that part of the fraction. I just solved it.
Write them out.
Okay. All right. So Eric just asked the other method. Is that what you're asking? The method we just did?
Go to dot b dot b.
Okay. Yes. Okay. So could I solve this in the expanded prime factorization form? Absolutely. However, you're going to be writing a lot of variables. 4 A's, 5 B's. In the bottom, you're going to write 6 A's. You absolutely can do it that way. It just gets a little tedious when all you have to do is really just subtract them, use some mental math. All right, so I want you to at least try this method on number 2, okay? I want you to work on simplify this fraction. All right, 10 over 24 reduces to? 5 twelfths, okay? Now, when I simplified my x's, what did I get? And was it a numerator or denominator? What is it? X to the third power in the denominator because that's where my larger exponent is. I subtract and write my leftovers in my denominator. What about my y? Y to the first power in the numerator. What about my z? In the denominator. Very good. You can kind of clean up your fraction bar if you want. And that's your answer. 5y over 12x to the third, z to the third. All right? Who got that right? You got it right. Very good. One more example. Whew, 5 examples today. We're doing good. In example 5, it says, are these fractions equivalent? Well, when I'm looking at them, just looking at them, I would think no, but I can't tell. Remember at the beginning of the lesson, we took the fraction 1/3 and we came up with all these other fractions that are equivalent, but they're in different forms. The only way I can tell is if I simplify both fractions in simplest form, then I can compare them. So that's what I want you to do right now. simplify both of these fractions and tell me whether or not they're equivalent. Yes or no? What is 12/15ths reduced? 4/5. What about 26 over 30?
13/15.
So is it equal? No. So just do the equal sign and line through it. No. All right, what about this fraction? These two fractions. All right, reduce them and then tell me yes or no. All right, so when I reduce them both, what do I get? 7/9. So yes, they are equivalent. You've got a couple of these on your homework tonight. All right, now we're going to take it one step further. What is the value of x? Yes, this is a challenge question. Okay, hold on. Write it on your papers. Write it on your papers. Don't say the answer out loud. Write it on your papers. What is the value of x? Write it on your papers. Don't say the answer out loud. What is the value of x? Andrew, what'd you get?
I got 20 over 20.
20. Very good. Because, and here's an easy way to figure it out. Some of you may have figured it out differently, but how do you get from 6 to 24? You multiply by 4. We call this the missing link. So 5 times 4 is 20. Okay, so that missing link helps us figure out that x equals 20. All right, this one's a little harder. Find the value of x. All right, so what's my missing link this time? 16. Hold on, 16 is my missing link, but now I'm going from the larger number to the smaller number, so 80 divided by 16 is what? Is 5. X equals 5. X equals 5. All right, if you understand that, this should be everything you need to know for section 4.3.